Thanks for the introduction. We're very happy to be here to give you a talk about SGLang. And I'm Ying Sheng, one creator of SGLang, and I will give the first half talking about the roadmap in the past half year, the first half year recap, and then also the next half year. And then Qiaolin will talk about one case study about GB200. Yeah, so that's the schedule. Let's start with some recap of what's happened in the first half of this year. We have about 5 strategic focus in 2025 half one. One focus about large deployment that we have. We have spent a lot of time on helping with the large deployment recipes, optimizations, and also practice in various industries. It contains throughput-oriented optimizations enabling enterprise-grade serving capabilities, especially with PD disaggregation and EP technologies for maximum efficiency at scale. In May this year, we have posted a blog post about deploying DeepSeek on 92 GPUs. And then in the middle of this year, we then scaled it to be several 300, 400, and then also 3,000 GPUs. And inside of XAI, the production serving has been scaled to, that's a different model, but it has been deployed on 100K GPUs using SGLang. And second focus about RL training integration, we also spend a lot of time, we also invest a lot of efforts in integrating SGLang and inference engine with many different RL frameworks, including Slime, Aerial, and Vero. And Slime and Aerial, actually, we have co-work with the team closely since the first day. And it has been also used in real production practice in various companies. In third focus, backward decoding, we have optimized it multiple times and enable low latency backward decoding implementations that reduce the inference time. We also have the SpecForge with a tool that can help you train the speculative draft model. In recent months, we still spent efforts on refactoring this part to make it further optimized. In long context optimization, we have enabled advanced memory management and processing technologies for handling extended context window with minimum performance degradation. Especially this year, we announced the feature of hierarchical caching so that you can cache the KVCache in GPUs and also CPUs, and also we have extended to disk. It has within the distributed storage, memory storage. And then another big part, the kernel optimizations, we have improved a lot in our kernels with close collaboration with NVIDIA. So hardware-specific kernel improvements maximize compute utilization and memory bandwidth for optimal performance. And this one example of what we said large-scale deployment, as I mentioned that it has been a blog post that we published in May. We have been the first industry, which always trying to achieve industry-first performance, and it is the first time that open source system that nearly matched the performance of DeepSeek official block with PD disaggregation and EP. And there are some performance metrics here that we achieved 52.3K input tokens per second per node, which is industry-leading input processing speed, and 22.3K output tokens per second per node, which is exceptional generation throughput. Overall, we have achieved the 5 times cost reduction compared to DeepSeek API pricing. And there have been more than 10 teams successfully reproduce the result. And this performance breakthrough, we hope it's like one example that has been validated that our architectural decision and positions SGLang as the on-go solution for organizations requiring enterprise-scale AI inference capabilities. And on the part of RL framework integration, some success story is we have worked with Aerial and Slime. Those are like SGLang native frameworks. They built those frameworks were built on purpose to leverage SGLang's full potential for RL training workflows with optimized performance characteristic. We also spend time on with the universal on universal integration that integrate with other like Vero frameworks that is more comprehensive with multiple inference, multiple rollout backend, and SGLang as one option. So SLime architecture highlights this. This is a very simple demonstration of how it's been designed. The data buffer sent prompts to this custom rollout generation. It's also one interesting component that designed in Slime that now other RL frameworks are also trying to learn from this design. That has a custom rollout engine generation, and then you can define any custom data generation scheme, and then it's sent to SGLang router. SGLang router then dispatch the rollout request to SGLang servers, and this enables a flexible definition of your own rollout logic, and also kind of separates the logic of SGLang development and the RL part, so that has enabled a smooth integration of the inference engine and the training engine. And the other part about community growth and industry adoptions, SGLang is now supported in RAID data, and support for SGLang in RAID serve, which is in work in progress. We have grown the community continuously. For now, there have been more than 800 contributors. The active contributors contributing code, documentation, community support, and from all over the world. And there are about maybe 30 people that's really actively contributing to it, working on it every day or every week. There have been more than 50 institutions, or actually maybe more, that using SGLang comprehensively. And should be more than 20, but actually more enterprise users, companies that are adopting SGLang as their default DeepSeek inference engine in the first month of release. And then, so that's what happened in the first half. And in the second half of 2025, their strategic priorities, we focus a lot on how like production reliability and enhanced usability. So we wanted to be, in addition to the great performance optimization, we also want you to find it easy to use and be closer to users. And others mentioned before, distributed cache. We have prototypes in the first half, but now we are still making it more comprehensive so that you can use more advanced features. And it has been currently practicing in real production workloads, but we always encourage more testing users. And hardware optimization, which is ongoing all the time. RL integration, which is ongoing all the time, and we'll release a new open source RL framework next week, so you can another fork built on top of Slime, and looking forward to that. About future compatibility and reliability, we're now supporting many features in SGLang and we need to then perform the combination of all major features. I mean, we have been working at the frontier of PT aggregation, speculative decoding, and all kinds of parallelism, all kinds of memory pool for all different attention mechanisms, and overlap scheduler, which has been able to reduce the CPU overhead so that we can hide all the CPU overhead and achieving 100% utilization. But those features, when they are getting more advanced, they have conflicts to each other. So the one focus on the second half is we want to make them all enable at the same time and within the best performance. So production level reliability, we are improving. We are improve our CI coverage, and it has been much better compared to like 1 month ago. And we also have more additional functionalities like crash, dump, replay, and report for debugging purposes, and has been developed a lot more than 1 month ago, and we can expect more in the next 3 months. On usability enhancements, we are working on SGLang cookbook, which aim to enable one-click deployment so that you can have a way to easily deploy to run it. And we are also developing a testing testing platform so that you can have a direct interact with SGLang engine served behind. And OMI integration, that's a Kubernetes operator for enterprise-grade LLM management, providing automated scaling, monitoring, and deployment orchestration. So for industry users to deploy SGLang engine on large scale. In router integration, we have improved it a lot, and recently we just released the Gateway 2.0 which is actually a bigger class than SGLang router. It enables intelligent traffic distribution and load balancing across distributed SGLang instances. And now it includes also like authentication and many other features like dispatching, model launching. Next generation kernel optimizations, we continuously working on CUDA kernel integration, and we have deep integration with attention and MOE kernels through close collaboration with NVIDIA. These optimizations target memory bandwidth utilization and computational efficiency for transformer architectures. We have improved many of the optimized attention kernels and their multiple attention backends in SGLang. We're making them to have the default setting to be the best though. And we also improved the performance for efficient sparse MOE routing and computation. On communication kernel enhancements, we have been working on faster or reduced operations across multiple nodes, optimized outward kernels for parameter sharing, and reduced the communication overhead in disaggregated architecture. On the part about advanced RL framework integration, we are expanding partnership ecosystem and continuing our successful collaboration with Slime, Area, and Vero frameworks to create the most comprehensive RL training ecosystem in the open source community. And we're always open to the collaborations with more frameworks in the future. And also we're releasing our own. So then the progress we aim to make, we aim to have full-scale model training, a simple documented recipe for fine-tuning complete DeepSeek and TiMi model families, for example, and also accelerated weight synchronization. We have done enhanced weight synchronization mechanisms that reducing training iteration overhead and enabling faster convergence across distributed training clusters. Asynchronous management, we have advanced techniques for handling long-tail scenarios and asynchronous operations in large-scale RL training environments, and we are integrating more features to make asynchronous rollouts more efficient. Deterministic inference, this as we have done some research implementation after following the blog post that published by Thinking Machine. Then we integrated their kernels, and then also in SGLang we enabled the deterministic inference and the deterministic rollout, and to within more advanced conditions, like when it can be enabled when temperature greater than 0, and it's compatible with chunk prefill CUDA graph radix cache to ensure reproducible results. And we're also working on true on policy RL that you can expect in a short time. And distributed KVCache system, that's for when in the production use cases that we have the data came in that want to have a high hit rate. We have hierarchical caching that's developed and now testing with the beta users, and also distributed architecture after we have the integration with Mooncake Store backend, Nixel backend, and DeepSeek 3 FS backend. We're also always catching up with the day 0 new model support, and there's some representative one, and there are more, and we're working on this, always working on this for the models. And strategic community building initiatives, we are establishing deep technical partnership with NVIDIA to optimize SGLang performance across their complete hardware stack, including Hopper, Blackwell, and next generation architectures. I think I can move to.
Yeah, let's now talk about deploying DeepSeek models on GB200 NVL72 with SGLang. So first I will introduce the background, then we will talk about the major techniques. Finally, I will show the benchmark results on GB200 NVL72. So here's the background. We published the blog in May 2025 about deploying DeepSeek with PD disaggregation and large-scale EP. And we published the follow-up blogs on GB200 in June and September. So as Ying said, we achieved very good performance on large-scale deployment on H100. And here's an example. We use 3 nodes for prefill workers and 9 nodes for decode workers. We use deep EP and DP attention to maximize the throughput. Why we choose expert parallelism and DP attention? Because DP attention will avoid duplication for KVCache, And the expert weights are partitioned across devices using expert parallelism, removing memory bottlenecks. We follow a dispatch expert combined pattern powered by deep EP and two-batch overlap to minimize latency and overhead. So let's talk more about two-batch overlap. The basic idea of two-batch overlap is you can divide a very large batch into two micro-batch, and then when we do the computation on the first batch, the second batch can do the communication. So the computation and the communication can be overlapped in that way. And for the PD disaggregation, it's very beneficial because peripheral batches will not preempt ongoing decode tasks in that way, and it can ensure more balanced DP attention. It's compatible with deep EP, different dispatch modes under DP attention. And KVCache transfer now supports non-blocking and RDMA-based transfer. SGLang also offers flexible API integration like Anyscale and Mooncake. Now let's talk about the major techniques. Because we are upgrading hardware from H100 to GB200 NVL72, then it means we will have enhanced memory bandwidth and computation, so we can use accelerated kernel execution. And because GB200 will have larger memory capacity, so it means we will have larger KVCache, larger batch sizes with improved kernel efficiency, and larger CUDA graphs. Also, GB200 will have larger NVLink domain, so we can have a pure NVLink solution, significantly reduces communication latency. So for the kernel optimizations, for FP8 Gen, we will use NVIDIA Blackwell Deep Gen for NVFP4 Gen. For prefer, we will use FlashInfo Blackwell Catalyst Gen, and for decode, we will use a FlashInfo Blackwell QDSL Gen. For BF16 attention, for prefer, we will use flash attention in QDSL, and for decoding, we will use TensorRT attention in FlashInfo. And for the FP8 attention, we will use FlashInfo Blackwell TensorRT attention. So here is the accuracy of lower precision. We can see in this figure, for low precision, it will not affect the accuracy scores. And if you use SGLang to serve your low precision model, it will not lose the accuracy. So I would like to share some benchmark results on GB200. For the low precision kernels, when we switch from BF16 to FP8 for the attention, we can see the latency will reduce maybe half. And for the Gen, when we switch from FP8 to NVFP4, it will also improve the speed by up to 1.96x. And for the E2E performance, we will achieve over 26K import and 13K output tokens per second per NVIDIA GPU for prefill and decode on low precision, which is much faster than H100. And also, it will also achieve very high performance on high precision. So thanks everyone for your listening. Any questions?
Hello. Thanks for the talk. I think that's very insightful. I think somewhere in your talk, you mentioned that there will be a new RL framework coming off the project. Can you expand that a bit more? And how is that different from Slime and Whirl and Ariel? Thank you.
Are you asking about the new framework difference? Yeah. I would say the new one we built on is similar to Slime, but we'll have some additional improvements on like fault tolerance, elastic training, and also some rollout algorithms, and then true own policy.
Thank you. Yeah.
some basic question. If you have to choose between VLLM and SGLang, like where SGLang actually, benefits better compared to VLLM, and then how the roadmap's going to be for both of these frameworks?
Yeah, I will say like we try to avoid to answer the question in a concrete way, but you're welcome to test it, benchmark in your workload, and I think each of them has some advantage in different workloads. So I cannot give you a single answer. But when you're using SGLang, you are encouraged to reach out to us to check if you are using it in the optimal way, and we always be there to help.
Yeah. So the answer is choose the fastest one. Yeah. Yeah.
I promise I'm not going to ask the question comparing another VLM model of this project, but my question was more around the silicon backend, like the type of accelerators that are supported by SGLang, because others are now supporting maybe a myriad of GPUs, TPUs, NPUs, and I was wondering what you guys are supporting through SGLang, because I saw CUDA, NVIDIA is well supported, but I'm curious about the other chips.
Yeah. We also support NPU and AMD accelerators. We have contributors from their companies, and they are actively working on SGLang on these chips. And I think it will also be very fast. And also we have SGLang jacks, which can run on TPU. Yeah.
Hi, just a quick question. You showed there was a 5x cost reduction for the DeepSeek implementation based on API pricing. How was the calculation made for your cost of the implementation?
You mean the low precision, or?
No, I think there was a slide that showed all the metrics, performance metrics improvements over the DeepSeek implementation by using wide EP and all the pre-filled decode disaggregation, but there was a 5 cost reduction compared to the DeepSeek API pricing. Now I don't mean to put you on the spot, maybe it's in the blog post or something, but I'm just kind of interested in, obviously you can look to their API pricing to get their number, but how do you define your cost?
Yeah. So our cost is because if you want to run the H100, you need to pay for the AWS or Lambda to run for the GPU. So the cost is the run for the GPU, and it's based on the throughput. So if the throughput is much faster than the price you pay the DeepSeek, then it will be much cheaper. The throughput and the price you pay for the AWS or Lambda, some GPU cloud.
Yeah, so basic GPU renting prices.
Yeah.
Yeah.
Oh, hi. I have a question regarding the MOE part. So basically, when I use SGLang to serve like a MOE model, and if I'm using EP, I'm wondering how does the workload balancing work here? So is there any mechanism for workload balancing with expert parallel?
We have the load balancing for the expert parallelism. We have a load balancer called EPLB, and it also supports dynamic load balancing. You can check it in our report, or we can talk offline.
Okay, thank you.
Just to dive deeper on the RL framework that you mentioned, you said that it would be slightly different than, let's say, Slime. Why not upstream those changes to Slime? Slime has been pretty sort of thoughtful about making SGLang the native framework, and my background is that there's a lot of RL frameworks, Scalar, Ariel, So what is the philosophical difference? Is it like more production scale? Is it more research oriented? Is it better integrated with sort of metric systems? Like, what are your philosophical thinkings there?
I would say, actually, in our mindset, if there's a new feature we developed, we have very good relationship with the other frameworks, so they will be upstreamed. So we'll have a new fork that we work on just for us to drive on our own pace, but the contribution we made, they will be submitted to the other frameworks as well, and we're already doing that.
Hi. Yeah, just on the low precision GB200 NVL72, you showed many different kernels. I wondered if you could show up the slides. I wondered, like, what was the actual, like, did you experiment with FP4 for different linear layers, attention, and then you kind of went, how did you decide which kernels to use based on, like, speed and evaluation accuracy?
Yeah, basically we will run the benchmark and gather torch profiling result and see which kernel is faster in the workload and then choose it. And we are trying to make them by default if they are the best one. So you can use the default config and gather best kernel.
Cool, thank you.
If there's no more questions, just want to add that we recently have making our Slack more public and open. You can just join slack.sglang.ai to join the community and discuss anything you want. We have now the Slack channels, public channels, more managed, and you can find the topics that you're interested in and start discussions there. I think we want to make the community work better, so encourage all of your participation.
Sorry, there's one more question. So just before you go, is there a way to deploy SGLang on Kubernetes clusters? Do you have like a Helm chart or like the equivalent of VLM production stack that people can just deploy on any cluster?
Yeah, we have the similar thing which is called OME. And you can check it in the SGL project organization. Yeah, it's in it. And you can use Kubernetes to deploy SGLang.
Perfect. Thank you.
In the SGL project organization, there are many repos which form the ecosystem of SGLang. So you can check out also the other project in the ecosystem, including that deployment tool.